Hello everyone. In the previous video, we studied about the PN junction diodes and its VI characteristics, its equivalent circuit. Let us now study about the Zener diode, which is another kind of diode. What is a Zener diode? A Zener diode is a one where the Zener breakdown is going to happen whenever it is in the reverse bias condition. As we all know, whenever the diode is in the reverse bias condition, there will be no flow of current. Once the flow of current is as and when we increase the reverse bias voltage, there is a voltage where there is a sudden rise in the current, and this current we call it as the reverse saturation current, and the voltage we call it as the breakdown voltage, where the actually device is going to enter into the breakdown region. Now Zener diode is one kind of diode where this is going to work, or this is going to conduct whenever it is in the reverse bias condition. When we observe the VI characteristic of the reverse bias condition of a PN junction diode, we came to know that the output voltage is going to remain constant as and when we increase the input voltage. Only the reverse saturation current was increasing, but the output voltage was remaining constant. So using this property, I can use my Zener diode to work as a voltage regulator. Now what is a voltage regulator? A voltage regulator is a circuit which is going to maintain a constant DC output voltage even though we are going to vary the input voltage. Now the very best example that I can give you is a stabilizer, where no matter whatever could be the input power supply to your stabilizer, it is going to provide you a standard output voltage, right? So this is what is a best example for the voltage regulator, where the stabilizer is going to regulate the input voltage to a particular and provides the output voltage to a stabilized, it is going to maintain a stabilized voltage at the output. Now, coming to this, let us first see what is a logic symbol, how the logic symbol of your Zener diode looks like. The Zener diode is going to have the anode plate as it is, but the cathode plate is going to have the extensions on both the sides. This is the logic symbol of your Zener diode. As we all know, Zener diode is going to conduct only in the reverse bias condition. Remember, Zener diode is going to work in the reverse bias condition. Now let us study how the Zener diode can be used as a voltage regulator. We all came to know that voltage regulator is a one which is going to maintain a constant DC output voltage when the input voltage is irrespective of the variation in the input voltage. Now, I know we are going to vary our input voltage. This input voltage can now be a line voltage or a load voltage. Now, what is this line voltage and what is this load voltage? I can use my voltage regulator to work with no load and with load. Now, what is this load? Load is nothing but an resistance connected across the output, where we are going to tap the output across it. Now such a resistance or such a current or such a thing, we call it as load resistance or load currents. Now Whenever we use a regulator with no load condition, I can say my IL, that is the load current, is always equal to 0. In this, we are going to maintain a constant output voltage even though when there is a change in the input voltage. Now, in order to maintain, that is, I'm going to vary my input voltage means there should be a limiting resistance which we call it as RS. Yes, this is what is your RS. So this is your limiting resistance where this is going to limit the current that is going to flow from the VI. Now no matter how much ever the current that I am going to increase across my input, my limiting resistance RS is going to limit the current across the diode. As a result, I can expect a constant output voltage at the output side. This is with respect to no load condition, right? This is with respect to no load condition. Now, once this is done, let us go for when there is a load condition. Okay, when there is a load condition, what is going to happen? With a load, let us study what is going to happen with load. Here, when you observe the circuit, we have the load resistance which is connected in parallel to the Zener diode, where we are going to tap the output across this load resistance. And I can say my V0 is nothing but my Vz. And when you look into the currents, you can see I have Is, that is, I have three currents, branching currents here. Okay. Now always remember, whenever you are going to connect your Zener diode to the AC input voltage, whatever, remember the polarities that should be, it should be in a reverse bias condition. That is, the cathode of your Zener diode should be connected to positive and the anode of your Zener diode should be connected to negative. Now, we know there is a presence of load here which is represented by RL, okay, and it is connected parallel to the Zener diode. The output voltage would be equal to the Zener voltage, which we name it as Vz. Now, the current, Zener current, which we call it as Iz, must always be above Iz min. The higher limit of current allowed to flow in the circuit depends on the power dissipating capability of the components used. Again, in this we have two kinds. One is the line regulation and the other one is load regulations. That is, in case of regulator with load, I have two kinds of regulation that is going to happen. I can expect one is the line regulation and the other one is the load regulation. In the line regulation, I can expect the series resistance and load resistance are kept constants. That is, the series resistance and the load resistance are kept constant, and it is assumed that all the variations in the voltage arise due to the fluctuation in the input minimum level. Okay, so this is what we call it as line regulation. And when we go for the load regulation, the voltage is a fixed one, wherein which we are going to vary the load resistance. The constant output voltage is obtained as long as the load resistance is maintained above a maximum value. So this is about the with load and without load. So I told there is a minimum current and maximum current to be established. So what is this minimum and maximum? So we came across whenever with load condition is there, we have the three branching currents, that is Is, IL and Iz. So my Is is equal to Iz plus IL. where my Iz is nothing but my Zener current and IL is nothing but my load current. When we express this Iz, I can write my Iz as Vi minus Vz by Rs. So the total Zener current Iz must be large enough to keep the diode in reverse breakdown. Yes, of course. Now, when we know the Is, can I not calculate my Rs, where the resistance Rs is equal to Vi by Vz into divided by Is. Now we know our Is is nothing but the combination of Iz plus IL. Substitute that, and once we get it, when the input is at the minimum level, then my Is is minimum. So Is of min would be equal to Vi of min minus Vz by Rs, and Is of min is equal to Vi of min, Iz of min plus IL. Similarly, whenever we are calculating the maximum, whenever we are we are giving the input maximum voltage, then Is max is equal to Vi of max minus Vz by Rs. Is of max is equal to Iz of max plus IL. So this is about the Zener diode and its application as a voltage regulator and the current concepts. Hope this video is very useful and this video makes you understand very well. Thank you.